All right, calculus. Welcome to another video. So for your calculus chapter 4 homework set number 2, help. Related rates homework is probably one of the tougher homeworks you're going to see this year. So I'm going to give you some help. Number 4, the ship question. All right, here's a little drawing. You know, if ship A is 15 miles east of P and is moving west, so it's going in that direction, you think dx dt is a negative right now because x distance is getting smaller. At that time it is. And then B is 60 miles south of P and is moving north. Okay, dy dt looks negative. What's the rate? You know, basically what's dz dt? That's a formula. You know, we're going to take the derivative of that. This is what we're going to be working with, okay? But folks, after 1 hour, that's what we really care about, guys. After 1 hour, you know, A is gone 20 miles, so it's actually 5 miles now west of P. So dz dt is not negative 20, but now positive 20, because at the time I'm, you know, analyzing this, this distance is getting bigger. That x distance is getting bigger. Now, dy dt is still negative because that y distance keeps getting smaller. So 45 is the distance away B is from P, because you just subtract 15. You know, that's the initial starting point. So Pythagorean theorem will give you z. Okay. And we know everything else. Okay. So that's the x distance, dx dt. That's the y distance, dy dt, dz. Or you know what z is. You're going to have to do some work there. And you're just looking for dz dt. All right. Help each other out with that one. Folks, number 5, I just want to say a volume of a sphere is 36 pi. You can find the radius pretty quickly. And then they already give you dv dt, so boom, just go from there. 5's pretty easy. I do like 5 a lot. Hint, hint, wink, wink. Now, handout number 6 is this. It's like example 21, the notes, and it's almost identical. I mean, it's pretty much identical to number 24, your notes. We'll have time. We can talk about that on Monday when I get back. That's probably one of the harder ones. But in the notes, I did change so that the horizontal and vertical distance should be the same. That makes tangent easier to work with. All right, number 10 had something to do with the surface area, right? If the surface area remains constant and the radius is getting bigger, that should tell you something about what the height's going to be doing. All right, so we need dh dt, where r is 10 and h is, you got to solve this to get h. All right, now you can pause this whenever, so I'm going to go quick. So that's the area for surface area. That's the formula for surface area of a cylinder. So d sa dt is equal to, you got to use the product rule here. Okay, derivative of the first plus the second plus derivative of this. Plug things in that you know. Again, we know the height, we know dr dt. All right, and then that's what you work with. Go from here. All right, just move this over, move this over. You're going to divide the pi's out. And you're going to divide by, looks like 20, and dh dt should be, so if surface area remains constant and dr dt is positive, don't be surprised if you get a certain answer sign-wise for dh dt. All right, 13, I'm not a big fan of shadow questions. You're just going to have them in your homework, honestly. 13 is this one. It says, a straight line is mounted to the top of a 15-foot pole. I didn't draw this to scale. 6-foot man walks away from the pole at a speed of 5 feet per second. So he's getting away. Again, this is the x distance because he's currently right here. That's the tip of the shadow. So dx dt is 5. And we want to know d, big capital D, dt. All right. Anyway, we're going to use similar triangles. Height over height is equal to big base over little base. All right. We get this formula. We're going to take the derivative of 9d distance dt is equal to 15 dx dt. I just did this question for you. You're welcome. All right. And then honestly, the last one, I did the last one for you as well. You're welcome. I might put together some another video with notes later. A 10-foot ladder. Okay, that's what's going on. We're looking there, top of the ladder wall. It's theta. dx dt is 2, that's 10. We need d theta dt when theta is pi/4 radians. What do we have here? We have opposite and we have hypotenuse. We're going to use sine. Sine of theta is x over 10. Take the derivative. Cosine theta, d theta dt is equal to 1/10 dx dt. Now, we're using cosine of pi/4, which is root 2 over 2. All right, dx dt is 2, so we have this. We're going to multiply both sides by 2 over root 2, and just simplify it. There you go. All right, that should give you a lot of help, because what was that? 4? That was literally a quarter of your answers, pretty much. All right, so in the previous video, you got a due date. This is Yak Math Video signing out.